Well, hello, everybody, and thank you for coming in today. As we mentioned last class, this class we're going to take as a pre-lab assignment. We do have an ocean stratification lab to do today based on data taken, and we're going to go through this lab. I'm going to show you how to set your graphs up. I'm also going to show you that we'll start off with the first thing. I did get the Unit 3 quiz review up. Now, we're not quite done with Unit 3 yet, but as requested, I tried to get it up as soon as possible. I put it together. So it is up, and it is with the quiz in the folder with the Unit 3 quiz. So we will be going through this next class when we finish up the material for the unit. We've gotten to right about here. Our next topic, we're going to do air and atmosphere introduction, which we're going to be talking about the Coriolis effect, cyclonic flow, seasonality, and things along that lines. So we've worked our way up through the layers of the ocean. So if you're scoring at home, you should be able to answer all of the questions or brief me on all of the concepts up to thermocline at this point on the quiz theory review. Once we finish the notes for the unit, which we wrap up next week with the air-sea interaction, we will run through the review. So just a note that it is up and it is in place for you. Now, generally, when we meet in class over the years, we've taken several class periods to do different activities that help reinforce the ocean concepts. We've graphed the tides when we did tides, and some of these get kind of complex. Today, we are going to be charting ocean stratification. So I wanted to take the time to go through this concept with you. The lab, I will start with the instruction sheet. Here's the instruction sheet. The beginning of it is a review of material. So let's talk a little bit about the material here. We talked about density and its importance. The density is here. My colleague, Sharon Gilsberg, defined it because she wrote this up as the degree of compactness. And that sums it up nice. It's how the particles that make up matter are arranged. If they're really close together, it tends to be more dense. And if they're farther apart, it tends to be less dense. And there are different factors that affect the density of water. The one that we look at the most is temperature and salinity. Temperature and salinity. So we have the concepts of density, temperature, and salinity with the stratification or layering of the ocean. So the first temperature is when we heat it, the volume increases. That's called a direct relationship, which means as one increases, the other increases. Water is unique though, because once you reach that 4 degrees Celsius, that's its maximum density, and then it starts to get less dense again. But generally speaking, temperature and density for most substances is a direct relationship. Salinity, we measure, the salinity is how much dissolved solids are in the water. And the average salinity of the ocean is 35 parts per thousand. We covered that. This chart here shows you the makeup of water. Just a brief, we've gone through it in class. Remember, chloride is the #1 dissolved solid, where sodium is #2, And then you have others like sulfate, magnesium, calcium, potassium. But really water, we're 96.5% water, seawater, and then 3.5% other. That's where you get the 35 parts per thousand. That's 3.5%. The more salt there is in water, the more solids there are in water, the denser water becomes. Another direct relationship. So we look at the CTD of water, the conductivity, temperature, and depth. Conductivity relates to its dissolved ions, the salinity, because electrolytes conduct electricity. So you can test salinity by how conductive the water is. The saltier the water is, the more conductive it is. So basically, there's bottles attached to this apparatus, and it's lowered in the ocean. Samples are taken at different depths. So each one would have an assigned depth. And then the conductivity is tested and the temperature is measured at each depth. So an apparatus like this is what is used in ocean research vessels. This is basically what we found out about the ocean. And I'm going to switch this to my view, because I have highlighted each area. Now, one we discovered and we named the surface zone. 2 is that middle Klein zone, and 3 is the deep water. 2%, 18%, 80%. Okay, so when we're looking at temperature, you have high temperature and then a thermocline, which is a sudden decrease in temperature, and then it stabilizes. The middle one, salinity, you have a variable salinity and then a halocline, and then you stabilize. And the last, the pycnocline, measures density. So you're cooling the water, the density is dropping. Then you have that quick pycnocline and then stable density. Because density is determined by salinity and temperature. So we've gone through that and we learned about the layer of the oceans last class. I just highlighted in the, because we learned that here about 200 meters in depth, that photic zone ends. So you start that intermediate water, and then around 1,000 to 1,500, somewhere roughly in this area, that intermediate water ends and everything is stabilized. Notice how stable our deeper water is. So and the water really does not mix very well. It really holds its integrity quite good. A couple of things to remember, being you have variable temperature, you have abundant oxygen. Oxygen is put in by the photosynthesis of plants, the photosynthesis of algae, mainly algae in the ocean, and then some atmospheric interaction, waves and stuff fold gases in. Down here, oxygen is still fairly abundant just because there's no, that downwelling, the sinking water tends to be oxygen rich, and there's not a lot of respiration, and you're getting some mixing where you have an oxygen minimum layer in the intermediate zone. Okay, so you basically have less oxygen here than you do here and here. Because this is the most isolated zone, you tend to also be a little nutrient deficient in this middle zone as well. All right, so here's the data collected. This, the apparatus is dropped down, water samples are collected, pressures measured, temperatures measured, And here's the data, which is done by the U.S. Coast Guard vessel, the Healy. This was taken from September. And notice your depths, the temperature readings, your salinity. Now this is, they say PSU, which is same as parts per thousand, the pressure, and then here's your density in grams per centimeter cubed. This is the one that we look at. Okay, this is done in STP, is standard temperature pressure. This is done in atmospheres. Remember, and so we're going to look at this density here. We're going to look at the salinity and the temperature. These three concepts. That's what we're going to graph. So we're going to make three graphs. Let's have a look at the first graph. I did the first graph for you. I didn't do the graphing, but I set it up. I'm going to expect you to submit 3 hand-drawn graphs on the graph paper provided. I know it's easier to copy, paste the data table into an Excel spreadsheet, print a graph, and be done. But one of the goals of this class is to be able to, one of the objectives in this class is to be able to draw and interpret a graph. And obviously, if your computer's drawing it, you're not. So in this exercise, you're provided with printable graph paper, and you will be hand drawing your graph. Graphs have a title. In this one, it is pycnocline, because graph number 1 was depth versus density and the pycnocline. Depth is on the y-axis. Notice it's upside down. You could easily put negatives in front of all of them, but you start at sea level and work your way down. Density goes across the top. As you can see, I put a little squiggly line here, and then we will start at 1. 0 is still the origin, but we zoom ahead to 1. So I write my density, units, depth, units. Now I have to figure what numbers to put there. I did the first one for you, and admittedly, the first one's probably the hardest. All of them use the same depth. So, because the depth is the same off the chart. So I went 1,000, so start at 0, 10 boxes, 1,000, so every box is 100. Every box is 102,000. Every box is 103,000. Every box is 104,000. I did that because on a piece of scrap paper, I did write it here, but on scrap paper, I wrote the range. 5.8 is the lowest, and 3551 was the highest. And then I looked at how many boxes I had, and I figured out the most logical way to arrange the depth. The most logical way is 100 points per box. Now, the tricky one was the density. We're not used to working with numbers that range from 1.019982, that's a lot of numbers after the decimal, to 1.029757. So I started with 1, and then I had to get to 1.03 evenly spaced so you can graph the data. I counted out how many per box, and again, 10 for every 0.01. So I have my 1 after the squiggly line from the origin, counted over 10, 1.01. Counted over 10, 1.02, counted over 10, 1.03. Now I have the proper range. So this first graph, I set up for you and just explained how to do it. do it that exact way. Then when you graph your data, plot your points and connect with a smooth line. It's not going to be a line, I mean a smooth curve. Being you probably already have the answers or close to the answers, because it's going to be a thermocline is going to be something like this, the halocline is going to be something like this, and the pycnocline is going to be something like this. So the goal here is to be able, but this is just a generalized graph from the book. You're using real collected data. So use your depth. Notice these are going to be really close, almost the same point. You're not going to get much on that. But now you're going to half a box, a whole box, more than a box, all the way down, and connect those dots with a smooth curve. It's going to be mighty bunched up top because they're going to be pretty close. And then you'll have the points a little more spread out as you look at the depth. So you're going to do that with density, which I charted for you, salinity, and temperature. Make note of the ranges, and then do your curve. Any questions? Okay, the last part is after you complete this. Now remember, the data is just the data. So once you connect it, you can see you wind up with some negative numbers here on the temperature range. So you're going to probably have to draw your chart a little differently there, but just follow the directions for each one. They're right here, graph paper, plot the points depth, salinity, plot the points depth, temperature. The same depth readings you can use from the salinity and from here. Draw a line through the point, and then you have your interpretive questions. The questions can be found on the 3rd page. All right, so part 1 from the reading. And then these questions are based on the graphs you draw. Please, you can type these questions out. Okay, I don't need these handwritten, just the graphs. Please, when you do, use full sentences to answer. You are in college, so, and don't just print this out and jam little puny writing in there. I don't mind it handwritten. You use a piece of lined paper, just write one. You don't even have to copy the whole question, write your answer. I don't mind you typing in your answer and then going to the next one. Just don't get like print this out and then write in like little puny handwriting, maybe a word and a half, and because that's difficult to read and not really your best effort. Then you can turn this and your pictures, snapshots of your 3 graphs into the Dropbox. This is due next Wednesday. That really is the goal of today, was to do a pre-lab and then allow you to do this on your own. I know that class is pretty short today. When you're in class, that's what we do, is we go through the pre-lab and then I give you the rest of the class to work on it. So that's what we're doing today. We just finished up the pre-lab and you will have the rest of the class to work on it. In the folder, you have 3 files. First is the file that we went through, the instructions and the data table. Second is printable graph paper, and you can print out as many sheets as you need. I recommend using pencil because I threw away about 4 trying to do my range to make it all nice and neat for you. Make sure you have the title of the graph, what you're graphing, the information, your points plotted, and your line drawn. Lastly, your questionnaire, that's the last file. You may type the answers right in or handwrite them on separate paper. Please, full sentences. Now, you are dismissed to do this lab. It is due next Wednesday. Remember, today is Wednesday, so you have things due for today as well. Have a great night, everybody. I will entertain any questions as they come up.
Thank you. Have a nice day.
Yep, you too, you too.
Have a good one.
Yep, you too.
So just to confirm, it's just the discussion that's due tonight.
Let me have, I think it's a discussion. Let me have a peek at my screen here. Oceanography, just give me 1 second. Live online. Today is the 22nd. Discussion Forum 3 is the only thing due today, yes.
Okay, thank you.
Yes.
I'm sorry, I've come too late.
Yeah, you did, but
Me too.
it has been recorded, so you should easily be able to watch it.
Oh, thank you.
Yeah, have a good one. Yeah, if you
Thank you.
watch it, you can email me questions because I'm sure you might have it 1 or 2 because you did miss the explanation, but it would help if you watched it and tried it before you did, okay?
Yes, thank you. Thank you very
No
much.
problem. Bye
Thank
now.
you. I'm sorry.
Yeah, I mean, it happens. It's, you know, you're not the first person to ever show up a little late sometime. I won't hold it against you. It's okay.
Thank you. Have a
Yeah.
great day.
Bye.
Bye.